Okay, good morning, class. All right, so last lesson we have studied what is the properties of the determinant. Oh, remember we have 10 properties of the determinant. All right, so today we are continue with 3.2.4 adjoint of 3 by 3 matrices. But last time we learned adjoint because we need to use adjoint to find the inverse of a matrix. But now this method is no more in STPM. Or STPM we are using other method to find the inverse of a matrix. Therefore, you can have a look on yourself. What is the adjoint? All right, what is the adjoint? And this is something extra that you see. Last time in SPM you have find the inverse of a 2 by 2 matrix by using this formula, right? 1 over determinant, A and D exchange position, B and C we add minus. Remember this formula? Yeah, this is the formula that you use to find the inverse of a 2 by 2 matrices, of a 2 by 2 matrix. All right, and this is the adjoint for 2 by 2. The adjoint for 2 by 2 is very simple, but for 3 by 3 it's a little bit complicated like this. Now you can study yourself if you think you want to do it. And this is the formula, okay, to find the inverse of a 3 by 3 matrix by using adjoint. The inverse of a matrix is 1 over the determinant adjoint M. All right, so this too is something extra that you can do it on your own. All right, so after adjoint we will continue this all about adjoint. Okay, that you can study yourself, okay, all about adjoint. All right, so now we will go to 3.3, the inverse of a matrix. All right, and now we are going to see how to find the inverse of a matrix. Okay, to find the inverse of a matrix, one of the method is we can use a concept. We don't have to go through the long steps. We just go through the concept so that we can find the inverse. All right, so after this part we will find the inverse of a matrix by using the long method, the row elementary method. Okay, so 3.3.1, the inverse matrix. So what is inverse? So let's say if A and B are square, yes, remember only square matrix has inverse. So if A and B are square matrices such that A multiplied B same as B multiplied A and both equal to I, means AB equals I, BA also equals I. Remember before this we already say AB not necessarily same as BA, but if AB same as I, BA also same as I, so if this happen, then B is called the multiplicative inverse of A. So means B is the inverse of A if this happen. All right, and A is called the multiplicative inverse of B. So another way around lah. So I also can say that matrix A is the inverse of B. Okay, so this is very important concept. Okay, now we replace B equals inverse A into this one, in here. So all the B become inverse A. So we will get this statement. Any matrix multiplied with its inverse or will be same as its inverse multiplied with the original matrix, and it must be equals to I, identity matrix. All right, so number 3, the inverse of a matrix is unique. Unique means all the matrix which has inverse will have only one inverse, or it won't have more than one inverse. All right, this is how we prove it. How we prove that the inverse matrix is unique. Okay, let's say if A multiplied B1 same as B1 multiplied A equals I, so we say B1 is the inverse, right? Let's say A multiplied with B2, so let's assume that B2 is another matrix. So when A multiplied with B2 same as B2 multiplied A also equals I, so B2 also the inverse of A, right? Then we start with B1. All right, let's say B1 multiply I. It can be happen, right? Because any matrix multiplied with I, you will get back the original matrix. All right, And just now from here we will show I is B, A, B2. Also, I sub this I become AB2. Alright? And remember, for multiplication of matrix is, what you call it? Associative. Associative means we can open this bracket and put wherever we want. Only bracket, not change the position of the matrices. Alright? So I open the bracket and I put it here. I bracket the B1A like this. And what is B1A? So here we will show B1A is actually I. So it's IB2 equals B2. So start from B1. I follow a few steps and I find that B1 is actually equals B2. Means B1 and B2 are the same. Therefore, the inverse is unique. Alright, so number 4. The inverse relation is symmetric. Okay, is symmetric. Symmetric means, you see, the inverse of the inverse equals to the original matrix. Alright, the inverse of inverse A, same as A lah. Alright, okay, so now we will see some examples which related to this concept. And by using this concept, we can find the inverse of a matrix. Alright, okay, I will discuss question 1, 2, 3, and 6. Yes. Okay, question 1. Alright, you can see it. So, question 1, you are given that matrix A, matrix B, and matrix X all are 2 by 2. Alright, and inverse A exists for the matrix A. So, they want you to express X in terms of A, B, and inverse A in each cases. So we are using the concept to solve this equation 1. To solve question 1. Okay, 1A. You are given AX equals B. So find X. Okay, we will start like this. AX equals B. So the next step, I'm going to multiply, because I want X ma. The question want me to find X. Means I don't want the A. So how to remove the A? I multiply inverse A to both sides. Alright? One very important thing that you must bear in mind when you do this step. When you multiply a matrix to one equation, remember, we cannot simply multiply matrix to one equation of matrix unless they are all square. This is very important concept. Okay, so when I multiply inverse A to both sides, you see, for both sides, I put the inverse A at the left hand side. AX. So I put the inverse A at the left hand side. This one B here. So I put the inverse A at the left hand side. Okay. When you multiply a matrix to one equation, you must make sure that you multiply that matrix to the same position. You cannot write inverse A at this side, but for this side, you put your inverse A here. Cannot. It's wrong. Because based on the concept AB not equals BA. Okay, so be very careful. Alright, so after I multiplied the inverse A, so we know that when inverse A multiplied with A, this is I. Alright, this one remain the same. And any matrix multiplied with identity, you get back the matrix. Therefore, matrix X is inverse A multiplied B. This is how we are going to do it. And we are going to use this concept quite often. Alright, okay, for B, XA equals B. You are given XA equals B. So this is AX, this is XA. Let's see what happened to the X. Alright, so again, because we want to find X, so I don't want A. So to remove the A, I multiply again the inverse A. Now you see, I have to put my inverse A at the right hand side of both sides. You see, this left hand side, I put my inverse A at the right. This is right hand side, I put my inverse A at the right also. Yes, please be very careful. Okay, so next step also, A multiplied inverse A is I. And any matrix multiplied with I is equals to X. Alright, therefore X equals B inverse A. So, can you tell me, A and B, are they the same? This X and this X, are they the same? Yes, definitely they are not the same. Alright? Okay, so for C, I want you to do it yourself. Okay, do it as homework. It's quite simple. All right, we will see D. D. Because there's something that I want to emphasize. Okay, you are given AX equals BA. So I want to find X. So again, I multiply inverse A to both sides. See, because I want to eliminate this A, so I have to put the inverse A at the left. All right, so do the right hand side. So I have to put my inverse A here and not here. Be very careful, okay? So again, inverse A is I. So I multiply any matrix, you get back the matrix. So look at the right hand side. Inverse A, BA. It's just inverse A, BA. Remember, multiplication for matrix is not commutative. We cannot simply change the position of the matrix. You cannot say, oh, I move my inverse A to this side. No, cannot. It's not a number. If only number can. For example, last time you learned, right? Let's say Z is A multiplied B multiplied C. These are all real number. Then yes, you can write A multiplied B multiplied C. You can write A multiplied C multiplied B. You can write C multiplied B multiplied A. If real number, yes, it's commutative, but not matrix. All right? So this is first question. How we apply the concept when a matrix multiplied with its inverse is equals to I. Okay. So second question. Number 2. You see, this is the method that how we find the inverse of a matrix without going through the row elementary operation. All right. So question 2, you are given matrix A, a 3 by 3 matrix, and B also another 3 by 3 matrix. All right. You are asking to find AB. Hence means that from what you have found, hence find inverse A. All right. So very simple. You are given A and B. The question wants you to find AB. So copy, please step must do. Sometimes they give 1 mark just to this step. All right, don't skip this step. Copy your matrix A, matrix B. Then do the multiplication. First row, first column, first row, second column, first row, third column, and so on. Okay, so you see, I found this. So the question wants you to find AB. So this is your AB. So your answer stop here for first part. Okay, now we want to find the inverse. Then you see that AB equals to this thing, right? And you see that actually this 8 can be factorized out. We can factorize out 8, and this is identity. So means that AB is equals to 8 identity. 8 is a real number. Yes, real number. Remember the concept or the rules that we have learned previously. All right. If numbers, yes, it is commutative. Not commutative, sorry, it's commutative, yes. So means that your number can shift here. So multiply shift here become 1 over 8. And this 1 over 8, you can put wherever you want. You can put 1 over here, can put 1 over here, can put 1 over here. Number can. Alright? So why I put here? Because the question want me to find inverse A. Alright? I'm going to use this concept when A multiplied with its inverse equals to I. Alright, so I put it here so that you see A multiplied with the matrix and you get I. So it means that by using this concept, it means that since A inverse A equals I, therefore this is inverse A. And this is another concept that we use quite often. All right, so please remember this method. Okay, so from here we can make conclusion. Inverse A is 1 over 8b. Don't stop here. All right, so you must copy down your B from the question. This is B. Copy here, and don't stop here also. The question want inverse A, so you must multiply your A inside. Yes, this is your final answer to get the last 1 mark. So remember, don't stop here, don't stop here. You must write out the full matrix. All right. So this is how we use the concept to find the inverse. So remember, when this type of questions given to you, when they ask you to find the multiple of when they ask you to find the product of two matrices, and from there you are asking to find the inverse, normally your product will be in the form or in the terms of I. Okay, so this is question 2. All right, next, question 3. So you see this question 3. This is not even given you any matrix, but we still can solve it. All right, so you are given A, P, and D are all 2 by 2 non-singular matrix. Still remember non-singular? Non-singular matrix means all these 3 matrices has inverse. And you're also given that AP same as PD. Okay, proof this one and this one. All right, it's very simple. We are using the concept A inverse A equals I. All right, I pull down a bit. Okay. All right, so you are given AP equals PD. All right, the question wants us to find A squared. So means I need to create A squared. So I don't want P. So to remove P, I multiply both sides by inverse P. Inverse P. So see, I'll put at the right hand side. This one also I put at the right hand side. Okay, then P inverse P is I. This one cannot rearrange. So A multiply I is A. Yes, I found A is P, D inverse P. So A square is AA. So AA. This is A. AA. So remember, I can multiplication of matrix is associative. Associative means we can remove the bracket, okay, and put wherever we want. So for this, you see, when I remove the bracket, I put my bracket here. Yes, so inverse P is I. See, so PD I D inverse P. PD I D inverse P. And any matrix multiplied with I will be same. So left D. Okay, and D square. Yes, I get A square. I already shown as A square equals this thing. All right, so how about A cube? So A cube is A square over A. So A square multiply A. So this is my A square. And this is my A. All right, again, associative. So I can remove all the brackets and I put my bracket here again. All right, so inverse P is I. Any matrix multiplied with I, same. So D2, D cube. Okay, so we use the concept like this quite often. So make sure you get used with this. All right, so this is question 3. All right, next we will go to question 6. We see one STPM question. So this is STPM 2012. You are given matrix A and you are given that A square equals inverse A. A square same as inverse A. All right, determine the value of X. 7 marks. All right, so you have different ways to start it. It depends how you want to start it. Sometimes it has different ways, yes, to do it. All right, so let's say I start with this. This is given A square equals inverse A. All right, so I multiply A to both sides. All right, because I want to create, I don't want to find the inverse A. All right, it's very messy. All right, so I want to remove the inverse A. So I multiply A to both sides. Okay, so this one become I. A cube equals I. I can find A cube easily, right? So I find A square first. A square. Later I multiply with A again and equals to I. So multiply lah. First row, first column, first row, second column, and so on. So be very careful. especially the sign, or the positive negative sign. All right, so this is a square. All right, this is a square. So multiplied with a, another a equals I. So again, multiply second time, I get this. First row, first column, first row, second column, first row, third column, and so on, and equals to I. Yes, so I have two equivalent matrix, so I can compare any corresponding elements. So I compare the first element. Use A better lah. I compare A1, the first element. So 3 minus x equals to 1. So x equals 2. Okay, you see, just a question like this give you 7 marks. All right. Okay, so you from here you can see that I want you to do 4, 5, and 8 as homework. Okay, so we will stop for a while. I want you to now you complete question 7. Sorry. Okay, you complete question 7 and 12 as quiz now. All right, 7 is 5 marks. 12 is 8 marks, 13 marks. So 13 marks means I give you about 20 minutes. So I'll give you about 20 minutes. You complete these 2 questions and snap the solution, upload to the Google Drive, the previous Google Drive that I give it to you. All right, the matrix, the Google Drive of matrices. Put in there. All right, so after 20 minutes, I will upload another video to show that how we are going to find the inverse of a matrix using elementary row operations. Okay, all right, see you later.